Welcome to the first course in the blockchain specialization titled Blockchain Basics. Let's start by asking ourselves, what is a blockchain? Why should you care about it? Unlike traditional methods, blockchain enables peer-to-peer transfer of digital assets without any intermediaries. It was a technology originally created to support the famous cryptocurrency Bitcoin. The blockchain by itself has taken a life of its own and permeated a broad range of applications across many industries, including finance, healthcare, government, manufacturing, and distribution. The blockchain is poised to innovate and transform a wide range of applications, including goods transfer, for example, supply chain, digital media transfer, for example, sale of art, remote services delivery, example, travel and tourism, platform for decentralized business logic, for example, moving computing to data sources, and distributed intelligence, example, education and credentialing. Additional applications of blockchain include distributed resources, for example, power generation and distribution, crowdfunding, for example, startup fundraising, crowd operation, for example, electronic voting, identity management, for example, one ID for all your life's functions, and government public records and open governing. Moreover, blockchain can enable an inclusive economy. It can enable a person in a remote corner of the world to partake in a democratic process. Opportunities for innovative applications are endless. There is a dire need for critical thinkers, designers, and developers who can envision and create newer application models on blockchain to benefit the world. This course is a first step in addressing this need. At the end of this course, you will be able to explain the three fundamental characteristics that define the blockchain using Bitcoin blockchain. Bitcoin is not the only player in town. By the end of the first module, we'll move beyond Bitcoin into introducing the next generation blockchains with Ethereum. You will also be able to discuss the important features of Ethereum blockchain that is used as a reference implementation in many newer blockchains, and explain the algorithms and techniques that enable the blockchain, including a public key cryptography and hashing. Finally, you will be able to outline methods for realizing trust in a blockchain. Let's begin with an introduction of Bitcoin. Two major contributions of cryptocurrency Bitcoin are a continuously working digital currency system and a model for autonomous decentralized application technology called the blockchain. Though our focus is on a general blockchain, we have to understand the working of the technology behind Bitcoin to fully appreciate the innovation of blockchain. We can all agree that the advent of the internet and the World Wide Web has transformed every aspect of our lives, from stock markets to street corner food trucks. It has enabled the technology explosion with Web 2.0 and the world of e-commerce applications. Around 2008-2009, when the institutions and markets we trusted were crumbling down and everybody was running away from the Wall Street, a mysterious person or persons called Satoshi Nakamoto introduced a new digital currency, a cryptocurrency called Bitcoin. Bitcoin enabled an innovative platform for peer-to-peer transfer of value without any central authority. With no central authority, how did Bitcoin realize trust and security? By implementing software programs for validation, verification, consensus in a novel infrastructure called the blockchain. Later on, in about 2012-2013, computational elements were added to the blockchain infrastructure that has opened up a whole world of possibilities beyond simple currency transfer. These innovations are significantly shaping the direction of Web 3.0, as you will learn in the next 4 courses. What is a blockchain? Blockchain is about enabling peer-to-peer transaction in a decentralized network, establishing trust among unknown peers, recording the transaction in an immutable distributed ledger. Let's understand centralized versus decentralized network using a common scenario. Consider a scenario where a customer wants to buy an item using her credit card. Let's enumerate the intermediaries involved in accomplishing this task. We have a credit card agency, we have a customer bank, we have a credit cards bank, we have an exchange, we have the merchant's bank, and finally the merchant. This is an example of a centralized system that we are so used to. Now compare this with a system where peers can transact directly with each other irrespective of where they are located. Functions of the intermediaries are shifted to the periphery, to the peer participant in the blockchain infrastructure. Peers are not necessarily known to each other. This is a decentralized system. How do we establish trust among the peers in such a decentralized system? By having a process in place to validate, verify, and confirm transactions. Record the transaction in a distributed ledger of blocks. Create a tamper-proof record of blocks, chain of blocks, and implement a consensus protocol for agreement on the block to be added to the chain. So, validation, verification, consensus, and immutable recording lead to the trust and security of the blockchain. Now I'll explain these concepts using another scenario. I'm lending Amy $10,000. This is one single peer-to-peer transaction. We both make a note of it on a ledger. What if I change my entry from 10,000 to 11,000? Alternatively, Amy changes hers from 10,000 to 1,000. To prevent this trust violation, we need to seek the help of people around us, Lisa, Allison, and Francis. Provide all of them a valid copy of this ledger. This is the basic concept of an immutable distributed ledger defined in a blockchain process. In this scenario, we were all physically present in one location, Immerse. Now imagine this to be an online transaction to an unknown peer. Also, scale up the one transaction to 10,000 transactions. How about 1,000,000 transactions? I should be able to transact with equal ease to any unknown peer in Immerse, Albany, or Albania. Maybe to send some flowers to a friend in Albania. This is the tenet of a decentralized system supported by blockchain. In the case just described, how do we trust our unknown peers? Through verification and validation. In our example, Amy requests Kevin to verify the amount I transacted with her. Kevin checks it. Oops. Kevin finds the amount of transaction is not 10,000, but 300. Not valid. Kevin rejects and nullifies the transaction. Similar to this, validation and verification methods defined by the blockchain and implemented by the peers provide the collective trust needed in a decentralized system. Summarizing, blockchain technology supports methods for a decentralized peer-to-peer system, a collective trust model, and a distributed immutable ledger of records of transactions.